systemd.path units turn the file system into a trigger source. When a file appears, changes, or gets written, systemd reacts. No cron schedules, no polling loops, just clean event-driven automation. A path unit is a systemd unit type that watches one or more file system paths. When a condition matches, it activates a paired service. Think of it as a notify wait wrapped into a unit file. Declarative, managed, and integrated with the rest of systemd. Timer units are time-driven. They fire on calendar expressions, boot offsets, and monotonic clocks, essentially cron on steroids. Path units are event-driven. They fire when the file system itself changes. Time triggers schedules, path triggers state. For directives form the core of any path unit. PathExists fires when a file appears. PathExists glob is the glob variant, matching patterns like star.log. PathChanged triggers on metadata or content shifts, like time or size moving. PathModified is similar, but tuned to the close_write in notify mask, emphasizing write completion rather than broader touches. A path unit never runs a service directly. It is pure glue. You point it at a sibling.service file using requires equals, and order the relationship with after or before. The path unit starts, sets up the watch, and lets the service handle the real work. Internally, systemd opens and notify watches on the configured paths. When a watch matches, it enqueues an activation job for the paired service, to bounce so rapid events coalesce into one trigger. The life cycle is idle, watching event, activating service, then back to watching. Path units shine in real-world automation. Reload and jinx the moment certbot writes a renewed certificate. Trigger a build pipeline when a deploy marker file lands in /tmp. Run log rotation hooks when a log file closes. Even emulate USB auto mount by watching device nodes. Pitfalls bite the unwary. Requires equals only, not the overridable variant. The target service must define execstart, or activation does nothing. User-level path units need a running systemd user instance. And recursive watching is not supported. You must list each file, or use a glob. Path units are event-driven, file-scoped, and always paired with a service. They give systemd a native way to react to the file system the moment state changes. That is systemd.path, the file system watched. A systemd.path unit is just a plain ini-style text file that tells systemd to watch a specific path in the file system and trigger a service whenever that path changes. Before writing one, we clear the screen and look at what already exists in /etc/systemd/system, so we know we are starting from a clean slate. We list every existing .path unit shipped under /etc/systemd/system. The to/dev/null redirection silences errors if the glob matches nothing, so the output we see is the actual set of path units currently installed on the host. Next we create a working directory and drop a Sentinel file inside it. This marker file gives us a real, observable target on disk that a path unit can later watch for creation, deletion, or modification events. Now we author the path unit itself using a here doc. Every directive inside the path section describes a file system condition, and the install section tells systemd when the unit should be active. The file we are about to write is the entire contract between the kernel's notify subsystem and our service manager. Reading the file back with cat confirms exactly what was written to disk. This is important because path units have no compile step. Systemd will parse this file at activation time, and any typo in a directive name silently disables that condition. Systemd analyze path parses the unit without activating it, and reports how each directive would be interpreted. It tells us which file system event triggers which condition and which service would be started, giving us a static validation of the on-disk anatomy we just wrote. We inspect the watch directory with a long listing to confirm the marker file is still there, when it was last modified, and its ownership and permissions. The timestamp and size are the actual notify attributes that the PathChanged directive will be matching against. Finally, list units. Type equals path shows every path unit systemd currently has loaded, so we can see our new unit sitting alongside the built-in ones once it has been installed. This is how you verify that the on-disk file has actually been picked up by the service manager and is being monitored for file system events.